Good afternoon. I'm Ann Aylward, Director of the U.S. Department of Transportation's Volpe Center, and I'm pleased to welcome you to the finale of Up and Away, Innovations in Advanced Air Mobility, our 7-part thought leadership series developed in partnership by the FAA and the Volpe Center. Today's program will focus on advanced air mobility and related workforce issues. Throughout this series, innovation has been an element of each session, but we've yet to focus on workforce considerations, which are foundational to the future of our aviation system and this emerging area. It's my pleasure to welcome back Lawrence Wildgoose, FAA's Assistant Administrator for Policy, International Affairs, and Environment. We very much appreciated working in partnership with Lawrence and his team, especially Terry Wadley, who serves as Acting Deputy Director in FAA's National Engagement and Regional Administration within Lawrence's organization. I'm also pleased to welcome 2 guest speakers today, Becky Luty, PhD, Chair of Graduate Studies and Associate Professor at Embry-Riddle Aeronautical University, College of Aviation Worldwide, and Robin Rydell, Partner, Aerospace and Defense, Travel, Transportation, Logistics, and Sustainability at the McKinsey Center for Future Mobility. Before I introduce Lawrence, I want to thank all of you who have joined this important conversation about AAM, and I would like to extend a sincere thanks to the 23 expert speakers who have shared their bold visions, insights, and experiences with us since we kicked off the series in November of last year. Each of you challenged us to think critically about the future of advanced air mobility. There are a few slides now scrolling, which will give you a sense of the levels of engagement we've seen during this series. We're delighted that there were over 2,600 registrants from across the transportation enterprise engaged in the series, and a very special thanks to the 1,800 plus who attended the live events, including all of you with us today. Your participation and engagement are so important to advancing this conversation. This series included engagement from over 370 representatives of state, regional, and local agencies and tribal governments from across all 50 states, private sector and nonprofit representatives, officials from 8 major cabinet agencies and other federal organizations, and representatives from 49 colleges and universities. Together, we had representatives from 5 continents and 34 countries tuning in, including some of our speakers, if you remember. Together, we had just a reminder that we will have a Q&A session following today's talks, so please type your questions in the Q&A box as they occur to you, and we'll get to as many of them as we can. So it's now my pleasure to introduce Lawrence Wildgoose. Lawrence was appointed as the FAA's Assistant Administrator for Policy, International Affairs, and Environment in January of 2021. In this role, he's responsible for leading FAA's policy efforts to improve the safety and capacity of the global aerospace system in an environmentally sound manner. His focus is coordinating FAA's reauthorization efforts before Congress, improving the safety and efficiency of the national airspace system, and advancing innovation-friendly policies related to the safe integration of new entrants, including uncrewed aircraft systems. He also oversees the agency's international activity, including advancing the FAA's global leadership on safety and environmental initiatives. Lawrence, thanks for being back with us to wrap up the series. The floor is yours.
Thank you, Ann, and good afternoon, everyone. I am grateful for this opportunity to close out this very exciting series of discussions with impressive thought leaders. I know today's session is about the workforce of the future, but if you've been following the series, I think you will agree that safely integrating these new entrants is an opportunity for today, not a challenge for tomorrow. In November, we kicked off this series talking about the potential benefits and improvements that we hope to realize as a result of AAM integration. But more importantly, we focused on how we will do this safely. In that first session, Deputy Administrator Katie Thompson explained how the pace of our integration work was intensifying and how our rules will allow AAM manufacturers to achieve our safety standards in innovative ways. She also spoke about the outreach we're doing on the local level, across government, and globally to usher in a new era of transportation. In another session, you heard from my colleagues, Assistant Administrator for Next Gen Paul Fontaine and Steve Bradford, the Chief Scientist for Architecture, and action development. They shared a bit of our UAM concept of operations, how we're validating operations through demonstration projects and the creation of an autonomy working group. Then just last month, the FAA's acting executive director of the Office of Environment and Energy, Julie Marks, spoke. Julie talked about how the FAA is working to understand the environmental impacts and community concerns of AAM, to anticipate, to minimize, and most importantly, to address them. Throughout the series, you have heard from various AAM manufacturers who highlighted progress they are making on specific aircraft and how this innovative technology will provide safety and sustainability benefits. The ever-increasing volume of work that is happening around AAM today compels us success, not only our future workforce needs, but our current workforce needs. AAM is here, and the hard work is happening now. So what does that mean for today's FAA workforce? Well, it's easy to talk about the unique skills that we need. We need engineers and scientists. We always need engineers and scientists at the FAA. But we also need policy experts, communication practitioners, accountants, finance administrators, and even lawyers and more. The aviation sector needs people across the full range of skill sets. For an agency that was created 65 years ago, we have learned a lot. For example, not all aviation noise is created equal. And for a lot of those 65 years, we didn't always do a great job of responding to local concerns about the impacts of aviation, but we're getting better. Our national engagement and regional administration team is leading the FAA's efforts to build stronger relationships with local communities. This kind of engagement is important now, but as AAM starts to integrate and operate in our national airspace system, it will be critical. The FAA's role is to ensure AAM is integrated safely, but if the public does not believe it, will it be successful? What if the public believes that the benefits of AAM don't outweigh its benefits? Could we do a better job of mitigating what the public perceives as potentially negative impacts? What does the public perceive as negative impacts? How do we integrate in a way that avoids creating or exacerbating certain inequities? We can't answer all these questions without community engagement. At the same time, we must address similar questions, plus technical standards globally. Our current international airspace system is seamless, and achieving the airspace system of the future is going to require even more cooperation and coordination, but at the speed and pace that is unprecedented. Not to mention, our integration efforts will drive the need for new policies, new regulations, and significant updates to our existing regulatory framework. We need open-minded people who can listen, who can communicate, and who can ask good questions. We need negotiators. We need community builders. We need problem solvers that live a good challenge. We need lots of different people from all walks of life. To sum it up in one word, the AAM workforce must be diverse. It requires a diverse set of skills, a diverse set of viewpoints, and it will require a diverse set of people. I will close out with this point. Growing the AAM workforce of the future is going to require a collective approach and a combined effort. Government, industry, academia, everyone needs to be talking about the amazing possibilities that lie ahead in this field. And no person, no skill set, no viewpoint should be excluded from the opportunity to work in the aerospace field. So thank you, Ann, and back to you.
Thank you, Lawrence. It's my pleasure now to introduce Dr. Rebecca Luty, Chair of Graduate Studies and Associate Professor at Embry-Riddle Aeronautical University College of Aviation Worldwide, and a member of the leadership team of the university's Boeing Center for Aviation and Aerospace Safety. Becky conducts research on a variety of topics such as safety policy, sustainability with a primary focus on aviation workforce development and the outreach, recruitment, and retention of women in aviation. She has testified before the House and the Senate on topics related to aviation workforce and women in aviation, and has been featured in more than 25 publications, a variety of academic journals, magazines, and book submissions. Becky was appointed by the Secretary of Transportation to the FAA Women in Aviation Advisory Board, which developed recommendations and strategies to the FAA and U.S. Congress to encourage women to pursue careers in aviation. She has served on numerous boards, including the National Aeronautics Association, and is the recipient of the University Aviation Association's Sorensen Award for Outstanding Achievement of Excellence in Aviation Research and Scholarship. She's also received the University Aviation Association's Larson Award for Outstanding Contributions to Aviation Education and the 99's 2021 International Award of Achievement for Contributions to Aviation. Becky is a former commuter pilot, active general aviation pilot, and owner of RV-7 and RV-10 experimental home-built aircraft. So please join me in welcoming Dr. Rebecca Luthi. Becky, the floor is yours.
Thank you, Anne. Thanks for that nice introduction. And thank you. I am really honored to be part of the wrap-up panel. This is just a great honor for me to join today's panel, but also that long list of distinguished speakers that you just showed. And I want to start by recommending to all, if you haven't had a chance to look at the series, check out the recordings because they're really fascinating conversations. I've learned a lot from them. So thank you again for the opportunity today. Next slide. So how do we find that workforce that Lawrence was just talking about? So that's what we're going to talk about today. And if you have watched some of the previous segments, you know that there's a couple of key themes that really popped out to me that I think relate to what we're talking about today. And that is the rapid pace of innovation and technological growth that's happening in AAM, and also just the growth, the market growth that we anticipate, both domestically, but also internationally, which was its own segment within this series. And in fact, Ms. Liu in segment 4 referred to AAM as the golden age of aviation. So that golden age of aviation is going to require a well-trained and prepared workforce. So today I'm going to talk about 3 areas within workforce development, training and education, and research. Next slide, please. So full disclosure, I pulled this slide from some work that Robin did, my co-panelist. So thank you, Robin. I enjoyed your work. And this slide represents a depiction of the activities that are involved in AAM with more than 50 different items that are listed here. But when I saw this, I saw jobs. So Lawrence just gave us a great list of jobs and occupations in AAM, but I think this also summarizes the field well. In addition to that, so of course, pilots and crew scheduling, but so many other areas that are going to be needed, from flight ops, dispatch, scheduling, weather, system engineers, software engineers, the development of vertiports and new infrastructures, fascinating, maintenance, and especially safety. Lawrence, I want to thank you. In the very opening section of the very first piece in this series, you talked about the importance of safety, and again today, safety integration. So it's the pillar, it's the main thing of what we do. So all of these areas represent workforce needs. Next slide. So how do we get there? I'm going to start by talking about how do we pull people into the industry and for AAM, and specifically looking at things like outreach. So this is a depiction of an outreach model I did a few years ago that just talks about some of the steps of outreach, from prep to targeting specific groups, engaging in the activity, sustaining the momentum, which is a key piece. We bring people in, we get them excited, we want them to walk out the door with next steps. And then how do we evaluate what we've done? So that's a little bit of how, but I really want to get to the next slide, if we could, and talk more specifically about, in terms of outreach, what are we doing well, and what are we, quite frankly, getting a bit wrong? So what we do really well in outreach in aviation, for example, is youth outreach. And we know this is critically important because the research tells us that age 10 and under is the key target age to draw people into aviation. We want to make sure we're targeting youth outreach at age 10 and under. So great programs around the industry to do that. You can see some photos here from the EAA Young Eagles. I'm a huge fan, volunteer a lot with Young Eagles. And of course, Girls in Aviation Day with Women in Aviation. OBAP, the Organization of Black Aerospace Professionals, has a whole range of outreach across a broad spectrum of ages. Sisters of the Skies has Girls Rock Wings. AOPA has curriculum, including high school curriculum. So we do a pretty good job at this part of it. But I want to talk about in general, our approach to outreach and where I think we can improve it. I tend to think we lean in too much or a little too STEM forward, if you will, in how we market and message what we're doing in outreach. So we know from research that what draws people into aviation is what I kind of call a cool factor. The fun, the passion for the field, the excitement, the desire to be challenged. I know when I decided I wanted to be a pilot, it was because, quite frankly, I thought it was cool and going to be a lot of fun. And it is. It still is. I was out flying the 10 last night, so it's still fun and cool, and I enjoy it. So my question to you, what was it for you? What was that first thing you remember that drew you into aviation? And so when we think about outreach, think about that. So if we lean too forward with STEM and we say, hey, come out to STEM Day versus come out to Girls Rock Wings Day, you know, which one's capturing that fun and excitement? The other issue here is if you're leading too forward with STEM, particularly for young women tend to self-select out of STEM at about junior high age for a variety of reasons, including social isolation and not seeing role models, you know, look like them in the field. So if we lean too heavily into STEM, we don't want to send the message that if you're not interested in STEM, aerospace, aviation, AAM is not interested in you. So we need to rethink the approach. The other point I want to make is influencers. And I'm not talking about TikTok influencers here. I'm talking about, you know, I asked you that question earlier. So again, when you decided you wanted to be in aviation or aerospace, whatever it was, who was the first person you told? What was their response? Did they know how to help you? And did they have answers for the process and the pathway? So we don't do, let me say this, we could do better at doing outreach to the influencers. And research shows us, again, that those influencers include parents. As a parent, it makes me happy to know that we still have an influence. And if you go to a parent, do they know, what to tell you and where to go next? And then the other point I want to talk about is counselors. So in a survey I did on women in aviation, counselors were not a major influence on their decision to join aviation. But when they were an influence, it was more often negative than positive, which ran the risk of steering them away. That's our fault. That falls back on industry to make sure that, again, we're doing outreach to these groups, giving them the information and the tools, or at least leading them to where they can find it, so that once we've done this great recruiting, we don't lose people in the pipeline. Next slide, please. The other area we have opportunities is to attract a wider audience. So, we can't fill the workforce needs if we're only targeting half the available workforce population. And in aviation, women make up less than 20% of most of the workforce positions. In particular, the biggest gap areas continue to be flight, where women are 5%, and FAA mechanics, percent that are women, is just under 3%. So there's a lot of opportunity here. Additionally, those numbers have remained relatively flatline and stagnant for decades. Next slide. We also don't do a great job of increasing representation in race and ethnicity. So this is a workforce growth opportunity for us as an industry. These are the latest statistics from the BLS from 2023, and you can see we've got a lot of opportunity for growth here. I also want to point out quickly what's missing in this data, because I think that's important to note as well. What we don't do a great job with is disaggregating that gender data into race and ethnicity. So we don't even count, for example, the number of women who are pilots who are also Black or African American. And I will say that as an industry, as an organization, and as an individual researcher, what we measure reflects what we value. So we can do a better job of that. Next slide, please. So how do we solve that problem? Well, that's a panel in and of itself, the underrepresentation issues to address. But what I would do is refer you to the publicly available Women in Aviation Advisory Board report. As noted, I was very honored to be a member of this group along with 30 women. We spent 2 years studying these issues. And what we found out is, of course, there's no one simple answer, but there's a complex system of barriers to the recruitment, retention, and advancement of, in this case, women in aviation. And so this report dives deep into those barriers and also offers recommendations in the form of solutions in 5 key areas as shown here. And I will just quickly comment that culture was the primary area that kind of overrode most of the recommendations, was weaved into a lot of the recommendation areas. And so if we don't address issues within culture in the industry, we simply won't be able to recruit, retain, and advance this broader representation of workforce. So I would refer you to that report for a much deeper dive of that discussion. Next slide. But I do want to spend some time talking about, of course, I'm going to talk about training and education. What I really want to point out, as Lawrence mentioned, lots of different jobs and lots of ways to approach this. And we need to keep the options open so we can meet people where they are and fill the needs for the workforce. So we have things like certificates. We have pro ed. So professional education allows us to draw workforce from other industries, bringing into AAM and bridge that gap of knowledge that they need to be successful in the industry. So we have certificates, pro ed, 2-year degree, 4-year degree, grad programs, all of which, of course, we offer at Embry-Riddle. But I will point out, as noted, there are 49 different education providers that have been a part of this series, as Anne pointed out in the opening slide. So if it's not us, there's somebody out there for you, and be sure to explore those options. And you'll notice that last bullet, yes, the professor is going to tell you there are jobs in this field that don't require a degree. So we also need to be prepared to train that workforce as well. But I want to comment on this last comment that's on the slide here about how fast-paced the change is. So as you notice here, I've got up the Master of Science, Uncrewed and Autonomous Systems. So this is a degree that we offer at Embry-Riddle worldwide. And I raise that because the leadership team from that degree came to us and said, we want to form an industry advisory board just for this area. That's not common throughout all the degree programs that we have, but I think it's an indication of how important it is to us to get this right for you, but also how important it is for you to engage with us, the education providers, so that we understand and can keep up with this fast-paced growth and the innovation and change in the technology that's occurring. So it's really important in training and education, meet people where they're at, have a variety of options for folks that meets the needs of the industry and the targeted workforce, and make sure that we're doing this in tandem, in collaboration. We need to work with industry, nonprofits, government, to make sure that we're getting it right. Next slide, please. And then last but certainly not least, I want to talk a little bit about research. So the workforce of the future will certainly require continued focus on research. What you're seeing here is the newest addition at the Embry-Riddle campus in Daytona Beach. That is the Boeing Center for Aviation and Aerospace Safety. What the Boeing Center allows us to do is tap into the over 2,000 subject matter experts we have across all the campuses at Embry-Riddle and focus on safety research. Why is that important here? Because it's critical for the workforce. And specifically in AAM, again, innovation technology, that theme that keeps recurring. It's a fast-paced changing industry. Innovation technology that's changing this rapidly. It's critical that we keep a focus on the human system safety interaction portion of our workforce development. So making sure that we're focused on human factors and the impact that this change has on safety and the human in the system. So that's just one of the areas that we're exploring. Always risk identification and mitigation, as Lawrence mentioned earlier in this session. AI is always a hot topic. It's been brought up several times in the series already. It's clearly a hot topic among those of us in education and training, but also in terms of how we're using AI in operations. So another research area to explore. And then always a continued emphasis on training and best practices, not just content, but in course delivery and training delivery. So some of the areas that we're looking at in Embry-Riddle. And again, I'm going to tell you that requires collaboration. We have to be able to work with industry and partners because we're going to need access to data. We're going to need to hear from you what you're seeing, what keeps you up at night in terms of safety concerns and how research can assist to address some of those areas. So next slide, please. So I will leave you with this, a call for action. So we started in the 3 areas of workforce development, training and education, and research. So if we want to build the workforce of the future, we're going to need to work together. And the call to action in these 3 areas include, under workforce development, outreach, do it, and think about how you're doing it. Rethink your approach, think about sustaining the momentum, thinking about the messaging, think about the influencers, but a focus on outreach. Clearly a focus on the recruitment, retention, and advancement of the best possible talent from the widest possible pool, and what we need to do to make that happen. Training and education. If you aren't currently working with an education provider or training provider, find one. Consider the options and how we deliver it, but engage with those providers so that we can help you prepare the workforce of the future. And that includes things like offering co-ops and internships. So training and education is an area to engage in. And finally, within research, collaborate. So join us and provide information to us so that we can keep that focus on research and continue to enhance safety, not only for operations, but for that workforce of the future. Next slide. So that is my time, but I want to thank you very much for the opportunity to participate today. As you can see, my email is here, so if you have questions or follow-up comments or anything, feel free. And all good researchers cite their sources. So that ResearchGate website under my name has got a lot of the research that I had talked about and mentioned. So you can find a lot of those sources right there. So again, thank you for your time. I look forward to the Q&A.
Thank you, Dr. Ludi. What a great presentation. We look forward to the Q&A. It's now my pleasure to introduce Robin Rydell. Robin is a partner in McKinsey & Company's San Francisco office, where he leads the firm's aerospace and defense, travel, transportation, and logistics and sustainability practices. He leads McKinsey & Company's global disruptive aerospace sector and the advanced industries disruptor sector in North America. Through his client work, Robin serves the whole ecosystem from OEMs to investors, from suppliers to operators and government agencies across geographies for both established players and startups. Please join me in welcoming Robin Rydell. Robin.
Thank you so much, Anne, and thank you so much overall for the Volpe Center and the FAA to host this series. What a fantastic way to get some of the thought partnership out there, thought leadership, and really been enjoying it. And hope today's session, will open up some other conversations, especially around the workforce of the future. And, for me, it's a very personal topic. I studied aerospace engineering and I graduated back in 2004. And the observation at the time was that out of my class of roughly 60 people, less than 10% actually ended up in aerospace, even though they had just studied for 4 years aerospace. And the reason was that, look, other things seemed more exciting and aerospace didn't seem that exciting at the time. So you fast forward to now, wow, like the things we get to do in aerospace now that's on the horizon, from eVTOL to sustainable aviation to drones to, the new types of new aircraft we're building. It's just a whole different world. So in a way, I wish I was 20 years younger and back in the early stage of my career, because I would probably gotten a very different path than I have if that was the case. And so given all these exciting things that are happening, I think it's not only a topic of concern of how do we get the workforce of the future, but also a topic that is actually a great opportunity because we can shape much with it. So with that, I have a few remarks before we get into the Q&A, just to share a bit of the thinking of how we at McKinsey have been thinking about the problem. So maybe next page, just to give a little bit of a framing here, and we've seen this in some of the other sessions of this series, is there's some big mega trends coming to aviation. Right? Electrification is a big one. We know electric cars on the ground, and maybe that will translate into some electric aircraft, and eVTOL, of course, has much of that. But even beyond just the aircraft, electrification is driving, more electric aircraft. Instead of hydraulics, we're using electrics, not just for propulsion, but for other systems. And so electrification is something that's shaping aviation right now. Digitization is another big topic, right? Whether that's in operations, or whether that's in designing. Like with the data that's available today, we can run operations so differently. We can design aircraft differently. We can run simulations. It enables a whole different design space. And so digitization is making things happen that even 5 years ago we couldn't think about. there's new ways of learning, and I think that's going to be very relevant for the workforce. You know, the way people learn today is just absolutely different than what I was used to, 20, 30 years ago. I remember the first time I got a cell phone, I would get the box, I would open the box, I would put the phone aside, take out the manual, and read the manual for 2 days before I even turned on the phone. Well, today's phones don't even come with a manual anymore. Everything is intuitive and kind of designed to learn by doing. And this whole new way of learning how to do things is coming to aviation as well, and we're adopting to it. And it has some challenges, but also a lot of opportunities. Another big trend here is sustainability, right? How do we think about the energy transition? How do we think about getting to net zero emissions for aviation and beyond? And what does that drive? Where does the funding come from? What are the technologies? And then the last mega trend I would highlight is shared mobility. 20 years ago, everybody kind of wanted to own their own car and drive around because that was the way to get around. But today, you can ride-hail other people's car that will drive you. You can get scooters that are scattered around the city. There's different ways to get around now. And now this is coming to aviation as well. So some of the big assets out there that, we would have never bought for ourselves are now available to us because they're shared. So these mega trends are kind of influencing not only the way we're building the future of aviation, but also how we think about the workforce. So with that, next slide, please. One quick thought here is I know the topic is really AAM, but that is a term that has many different definitions. And I just wanted to expand the scope slightly as we have this discussion, because yes, there's always eVTOL and urban air mobility, which sits at the core of AM. And then there's kind of the drones, whether that's small delivery drones or large cargo drones or inspection drones. But then there's other topics that we should consider here too as we think about the future of aviation. One is sustainable aviation, right? So even if we're building large narrow bodies with different propulsion systems, that might not seem like AAM, but it has similar implications. We're going to have a different workforce dealing with that. And then supersonic and hypersonic, as it emerges again, has some implications as well. The people will need to operate some of that, and to design some of that will need to have very different skills. And so just keep in mind that it's not all about eVTOL. eVTOL is a big part of it, but it kind of goes beyond that. Next slide, please. So this is an industry that's having actual traction. I always hear people asking, well, is this really real? Will we really have flying cars? Is this really something that's on the horizon? And the reality is, yes, it is, right? These are some of the statistics here on why I believe that. We have the traditional ecosystem heavily involved. We have lots of test flying going on. We have billions of dollars in funding going into it. And so I think it's pretty clear that over the next couple of years, this transition will start to happen. We can debate how quickly it will ramp up, but I don't think there is a question that this is the future. So what could this look like? On the next page here, we've kind of just taken a stab at, if you think about eVTOL and think about what some of the operators are suggesting, what would that look like compared to today's airlines? And these eVTOL operators would rival the biggest airlines out there today, right? In fleet size, they would even have more aircraft. In flights per day, because they're short flights, they would have almost an order of magnitude more flights per day than even the largest airlines today. Now, in terms of network nodes and active pilots and passengers per day, of course, they might scale slower because they have smaller aircraft. But overall, you see, these operations are going to be big and complex. And so, instead of kind of thinking of this as, oh, there's a novel little piece out there that might be a niche kind of market, I think it's relevant to think about, hey, what if it actually does scale up? What do we need for that? And, the active number of pilots here for an airline, would be about half of that of a major, traditional airline. That's a pretty significant number, especially in a time of pilot shortage. Next slide, please. So now, what does that really mean? Where are we moving from when we talk about this future aviation? And we've kind of taken a step here to talk about some of the skills and capabilities that we'll need for this. And so let me kind of walk you a little bit through this. I think across the areas of design, manufacturing, and operations, we'll see real significant change. On design, for example, to pick one out, today we're designing aircraft in a very traditional way. It's usually a tube and fuselage design, and very much in subsector and subcomponents. So, you have someone designing the engine, which is, fairly removed from the rest of the aircraft, right? We have a very efficient interface in the pylon. So engines can be kind of somewhat designed independently. Or you design, certain sensors, also mostly independent of the aircraft. Well, what would happen as we're getting towards, these air mobility topics, the aircraft will get much more integrated. If you have an electric propulsion system for aerodynamic reasons, for structure reasons, for thermal management reasons, you'll have to include that and integrate this propulsion system much more into the airframe than we have historically done. And so that really changes the way we think about design, but also changes the skill set we'll have to have. Another one on the design side to call out is high voltage electrical systems, and the engineering of that is something that in aerospace we're not that experienced with, and we'll have to learn a lot about and actually build up a real capability around this. And so similar things are true for manufacturing and for operations, right? Today we have 2 pilots in most cockpits. Well, we're going to go to remote supervisors who might, 2 or 3 supervisors together might operate 50 aircraft. Very different kind of skill set that might be required for that. Similar for maintenance, right? We're going to have much more distributed networks in a way, and much more line replacement unit-based maintenance where you swap out pieces versus some of the troubleshooting we'll do today. And so that'll change the skills we need, right? Much more focus on digital skills and software development, much more focus on multitasking in a way. Continuous learning and keeping up with technology will play much bigger of a role. And some of the things that historically were in the center for aviation, whether it's manual flying or kind of mechanical skills, are going to have to take a little bit of a step back as kind of these new skills come across. So in terms of the sheer amount of people we'll have to train for this, we've tried to take a stab at this, and we'll share this on the next slide here. And I would just caution this with the fact, like, we don't really know what the future looks like, how quickly things will scale up. So rather than an accurate forecast, look at this as a potential scenario that we might hit. But this just shows you the operating workforce, right? Design and manufacturing would be on top of that. But we're talking about pretty significant growth here over the next, call it 10 years or 8 years from now. Where we're not only seeing traditional aviation workforce growing as airlines expand, air traffic expands, but where we're also seeing the AAM workforce coming in with hundreds of thousands of people, whether that's pilots, whether that's ground handling and managing kind of the vertiport infrastructure, whether that's maintenance. Those are going to be real roles emerging. And again, in many cases, with a pretty significant difference in the skill set that's required compared to what we do today. So one example of how we get there is we're going to have to train people differently and hopefully really change the roles themselves. And for pilots, that's a particularly interesting one. So I wanted to spend a little bit of time talking about how we think about this for pilots potentially. Next page, please. So there's a concept out there called simplified vehicle operations. The idea behind simplified vehicle operations is to say, look, if these aircraft are that different, maybe we can train differently. Right? So today's traditional pathway would be to get a commercial pilot's license and maybe a frozen ATP. You work through your CFI and you work through your multi-engine. You'll probably have to fly 250 hours before you can start really, doing anything commercial. And then you have to, gain your hours until you hit 1,500 hours. And so it's a pretty long path, probably about 2 to 3 years, maybe a bit more even, probably close to $100,000 by the time you're done with it. And along the way, you're learning a lot of valuable information and a lot of valuable skills. However, if your operation is focused on, let's say, urban air mobility or electric vehicles only, you would learn a lot of things that you might not need. If I'm going to fly an eVTOL between cities or within a city, I don't really need to know high altitude aerodynamics. I don't really need to know, combustion jet engines, topics. I don't need to know global weather patterns. Right? And so I think there's a number of content that if you really said, hey, what if we train pilots only for these simplified vehicles? There's a lot of curriculum you could take out on the one hand. And even on the manual side, these aircraft are very different to fly. I've had the opportunity to fly about a dozen different eVTOL simulators by now. And I'm always surprised just how easy it is to, gain general proficiency with just moving the aircraft from A to B. They're very intuitive. There's a lot of computer augmentation, of course, that helps with that. But if these aircraft are that easy to fly, do we really need 250 hours to train a pilot? Or could it be different? And so as we're thinking, what does the training curriculum look like for pilots, right? Where's the opportunity here to really reduce the time it takes and the cost it takes? Because that will have a whole bunch of benefits to the kind of people we can attract. And of course, we heard a little bit earlier from other speakers on that topic. So with that, a few clothing thoughts from my side on the headwinds and tailwinds on the next slide here, please. two big tailwinds that I'm really excited about as we think about aviation talent for the future. I think the first one is really the improved access to aviation. And what I mean by that is today, again, when we think about pilots as an example, you would have to have exposure usually early in life to even build the excitement. And we heard a little bit about this already. And then, Becky talked about, even if you find that excitement early on, it's a pretty steep path to get to a commercial rating and really a role within that. And if we can reduce the cost to doing that and the time required to do that, we can open up this profession to a whole new group of people, whether it's different socioeconomic backgrounds, whether it's different family backgrounds, etc. So that's the first big tailwind, I would say, that gets me very excited. The second one is somewhat related. It's the more attractive local roles, right? One of the reasons we see people drop out of the pilot profession, for example, is because as you kind of progress, you're spending more and more time away from home. And that is really hard to manage. If you have, elders to care for, if you have kids to care for, it's not easy to, fly a typical schedule because you're spending a significant time away from home and you're working at nights and off hours. Well, I think AAM offers an opportunity to say, well, there's more local jobs, whether that's on the airport context, you might have a vertiport in your neighborhood versus just an airport, in one place in the city. Or you might have just local flights. You could go fly 8 hours and be back home after the shift. And so as we're kind of developing these roles in AAM, I think it will increase the attractiveness of aviation to people, and again, open up a whole new population that might want to have a, enduring career in aviation. And then the last thing, and that's really a headwind that I would call out here, is we're going to have to compete here. If you go back 20 or 30 years, you ask people, kids in high school, what do you want to be? There was still a pretty significant amount of people who said, hey, astronaut or, pilot. That has actually changed in the statistics. Today's, most mentioned are, a social media influencer or TikTok star, believe it or not. And, after that comes software development, and the astronauts and pilots are actually quite a bit down the list by now. And so part of the question here is, as we're having more transferable skills, right? So software engineers, how are we going to convince them they should work on the next autonomous aircraft program rather than on the next computer game or, the next AI chatbot that, creates different experiences? So there is going to be competition as these skills are more transferable. And so as aviation, we got to do a lot about our outreach. And I love what Becky, mentioned on that topic. And with that, I'll hand it back to you, Anne, and looking forward to the conversation.
Thank you, Robin. And I have to say, your airplane collection on your shelf is the most amazing collection I've seen in a really long time. So
thank you. I appreciate that.
All right. So unfortunately, Lawrence had to drop off the call, but I appreciate both Becky and Robin being available to take questions. We have some really good questions in the Q&A box. If you would like to add yours, please feel free to, and I'll get to as many questions as I can. Question that really could come to both of you, I think, is that Robin had an excellent point about aerospace students ultimately taking jobs in other industries. My aerospace engineering graduating class in 2009 was similar, with only about 20% of the class taking jobs in aerospace. I think excitement is one consideration, but also we need to consider other issues such as competitive pay and work-life balance. What do you think the industry can do to compete with other industries for talent? And Robin, you touched on some of that, but I wonder if you'd like to expand a little.
Happy to. Let me give you a few thoughts. I really want to hear from Becky too on this. Look, I think pay is one thing, and aerospace at times struggles with that. But what I've found working with aerospace companies on this talent question is that pay is often what I would call table stakes, but it's not what makes the difference. And it's not that people are really competing by paying a little bit more to get the talent. I think especially the newer generation is much more focused on what is my experience going to look like, right? That includes work-life balance, but also who do I get to work with? How do I get to engage? There's also a big question around what's the purpose, right? I think we're seeing a lot of employees these days, especially in the younger generation, really wondering about what am I working on? Is this something that's aligned with my personal values and my own purpose? And I think aviation has a tremendous story to tell here. And sometimes, to be honest, we undertell it. I mean, aviation really connects people. If you think about visiting other countries, learning other cultures, I would even argue aviation is one of the key drivers of peace in our modern world, because the understanding and facilitation of cultural exchange it enables is a big part of that. And if we look at advanced air mobility, there's going to be so many amazing use cases that are going to make the world better. You know, you look at what some of the drone companies are doing, and we had Oklahoma on the series earlier, right? What drone companies are doing to make vaccines accessible and medication accessible throughout Africa, right? What's going to happen in terms of equity when we really get this right and people can, you know, access bigger cities from the remoter areas, when e-commerce can actually reach into the remote areas because drones enable it, or there's so many incredible things we'll do for society with aviation that we should talk about and celebrate. And then the last one, and I didn't even mention it, is sustainability. The new generation cares a lot about the planet for good reasons. Well, this is a big push for sustainability. So I think giving purpose is probably the big piece we can do, especially if, you know, financially we don't really can compete with some of those you know, digital companies at times. But again, I don't think we necessarily need to. I think, you know, purpose will play a big role here. And then, of course, how we actually work. But Becky, over to you. Would love to hear what you're thinking.
Robert, I couldn't agree more. I mean, I think you summed it up really well. So I'll just add a couple of quick comments to that. One is, yes, pay, competitive wages, work-life balance, benefits, paid leave, all those things are critical factors. It's not going to be the single factor that draws them in, but if it's not right, they're not going to stay. So that same research I talked about earlier on recruitment, I didn't address this there, but I also asked, you know, about retention in that research. And guess what the big 5 things were that kept people in this industry? The same big 5. It's the cool factor. It's the fun, the passion, the excitement, everything that Robin just said. So what we need to do is make sure that we get those basics right, but also we need to get the word out. You know, if only 20% of that class went to aviation, they didn't know how cool AAM is and what's happening here because we didn't sell it. So we need to do a better job. So come to campus, show up, talk to our students. You know, I think the awareness factor is a big part of that. Internships, co-ops, again, helps get the word out and draw students in, you know, so I'd put in a pitch for that. But I couldn't agree more, Robin, with what you said.
Thank you both. So another question. Many industries and the federal government are eliminating the requirement for degrees. Since aviation is a technical field, how much of a push is there to just rely on certificates or no further education in this technical field? It seems like a dichotomy.
Yeah, happy to tackle that one. Oh yeah, we're seeing that a lot, right? No degree needed. More and more in this field. So 2 points there. One, that's just that much more of a support for the fact that, as I mentioned earlier, we've got to have options in training and education. So if a 4-year degree might not be right for that role, but maybe a certificate program, maybe pro-ed, maybe 2-year, maybe again, no degree. But the second point I want to make here, I find this really interesting that we're seeing that conversation more. And yet last term, we had record enrollment at Embry-Riddle in the history of Riddle. At Worldwide, our numbers are soaring, and I know the 49 other universities that have been involved in this program will probably say similar things. You know, our enrollments are up, capacity is the issue. So it's not so much that it's not required, but I think they're seeing value in the information and the knowledge and skills that they're getting in order to prepare them for the work in the field, not only to be initially get the job, but to advance in that career field.
Yeah, I would add a few things. I think that's generally the way, you know, I would see it. I do think optionality and flexibility is important. You know, having grown up in Europe, I always contrast, you know, Europe's pilot system, you know, pilot careers with North Americans. They're very different, right? In Europe, you typically don't go to college to get an airline pilot's license. You start flying the big jets with 250 hours. And, you know, those places have good safety systems too. Whereas in the US, you know, there's often a college involved and there's often 1,500 hours involved, right? And both systems are good and work, but they're different. And I think we just got to embrace the fact that there's different ways to get to an answer. I think when it comes to degrees, the interesting question really is, what do you get out of that, right? And I think I always look at it as 3 different things. On the one hand, you learn how to learn. And I think that is incredibly valuable for your life, because you're going to have to keep learning, and more so than ever, right? Because technology and businesses are changing. And so the ability to learn and knowing, hey, where do I get new information? How do I re-challenge my assumptions? How do I update my knowledge? That is a skill that you're going to have to learn, and colleges are great places to learn that. I think the second thing is problem solving, right? It's almost, not that important what content you learn, but that you learn really going deep into something, learning to structure, learning the problem solving. And again, college is a great place to learn that, but you can maybe learn in other places too. And then the last thing is the content itself. And to be honest, that's a bit hit and miss, right? Because there's some roles out there, right? Maybe, traditional aerospace engineering, right? If you're an aerodynamicist and you want to design airfoils, I have a hard time imagining you could do that without a really solid academic knowledge base to do that. But there's other things like software engineering where, we see people learning on YouTube and online courses having, just the same effectiveness as someone going through a college program. So I think it really depends on what we're talking about, the skills you want to learn. And I totally would feel happy with hiring more and more people without a formal college degrees, as long as I can see that they're demonstrating having learned these three things, right? So ability to learn, ability to problem solving, and then some content that might or might not be relevant, to the topic itself. And so I'm very much looking forward to see how the overall academic world is going to adapt to this, because I think the traditional framework of degrees will have to loosen up a bit to enable all of that.
I agree. I don't know if any of you watched FAA Administrator Whitaker's testimony before Congress last week, but one of the issues that was raised with him innumerable times is making financial aid available for certificate programs as a way of attracting professionals into the aviation job market. So be interesting to watch what happens there. Another question that came up a lot in those hearings is related to the question asked here, which is, what do you see the impact of AAM on the air traffic controller sector?
I'm happy to start, and Becky, your research on this has always been, Riddle's research broadly has been helpful, so you should weigh in here as well. But I think, look, in the near term, probably we have our own challenges in ATC with some of the shortages and some of the technology updates we're doing, like next gen, et cetera. And so I actually think AAM is probably not play the biggest role as you look at the next couple of years. We have bigger fish to fry, so to speak. But in the medium term and longer term, of course, we'll have to figure out the integration of these new, this new traffic in the airspace and how we manage that. And of course, concepts like unmanned traffic management will start playing a bigger role, right? How do we automate some of the controller functionality? And I would even argue, how do we augment the controllers we have much more with technology that we have available, right? And we've been slow in general to get technology into the hands of our air traffic controllers. And there's so much more opportunity to, take some of the tasks that can be done by a machine out of their hands and have the machine augment them so that the controllers can really focus on the things that humans are good at, right? And so I don't really see us getting rid of air traffic controllers in the traditional sense, because I do think humans have so much to add and such an extra layer of safety as a result. But I do see that we can make much more effective use of technology. And I think that will change some of the requirements of the job. I think, some of the requirements will shift more to, being comfortable with digital, being able to engage with automation in a different level, being able to understand the logic that machine will go about in a different way than we do today, right? So I do think there's a bright future for air traffic control and the human aspect of it. I do think, just like any other profession, there's going to be changes to what's required to do that. Becky, what have you guys found on this?
Yeah, again, Robin summed it up very well. So I think, in our role, looking at obviously the education and training provider, preparing that next generation of air traffic controller and what this means for the job skill change or transition, if any, and addressing what those needs are going to be is going to be key. But I think from a workforce standpoint too, it's even broader. We're talking about ATC and air traffic controllers. But as Robin pointed out, when we talk about the key area of integration into the national airspace system overall, which is a bigger topic than beyond just the ATC operator, that again opens up that workforce discussion. So we're talking about policy and policy analysts and regulatory environment and legal and all of those different areas that I think we just need to continue to focus on as we look at, the ATC and AAM integration.
So this next question is in some ways more of an observation, but an interesting one. The participant says, in fact, the aerodynamics requirements for flying in cities for these aircrafts and drones are far more complicated than flying at 30,000 feet. This is because of the buildings creating multiple vortexes for the flowing air, which creates a complex maze of operating conditions for these airplanes and drones. This is applicable for flying even over the buildings because the same phenomenon in a different elevation. I don't know if I see Robin nodding. I don't know if you'd like to comment on that observation.
I think it's a great observation in that we're operating in a different environment, probably more complex environment, right? I mean, look, high altitude has its own challenges like temperature and pressure, right? Which we shouldn't underestimate. So I'm not sure it's harder flying high or harder flying low, but I do think it's a much different complexity that we haven't dealt with in the past. But this goes a little bit back to the mega trends I mentioned earlier. We now have capabilities to do things we could only dream of even 10 years ago, right? So when it comes to aircraft design, right, the ability we have today using, let's say, AI surrogate models in engineering or other modern engineering ways to just test out different designs, to iterate the design, to test it in simulation in different environments, enables us to make much more progress in developing safe systems on the engineering side, for example. Similarly for the operation itself, right? The ability to put flight controllers in that have many more sensors, much more ability to really, engage with the environment and making it safe, right? When I learned flying 25 years ago, we didn't even have GPS, right? We still had a paper map in our hand and looked out the window and we're hoping that visibility didn't go down any further. Look how far we've come. You have a moving map now on your phone or on your iPad in the cockpit, and you know always exactly where you are and where the terrain is. And just that kind of technology progression we'll see come into these vehicles. And yes, it's a more complex environment, flying through urban canyons and managing the micro weather and thinking about the wind, etc. But we're also going to have much more capable aircraft, both from a digital perspective and from an engineering perspective. Electric propulsion or distributed electric propulsion, much more faster reactive, much more easier to control than the traditional machinery. I mean, the technology is going to enable some of that. And so I think the observation is fair, much more complex problem. I think we're well equipped to start tackling it.
Becky, anything you'd like to add?
Nothing major to add again to Robin, except to say this, we thought the same thing about how challenging and what a demanding environment was when we had barnstormers and, when we have introduced crop dusters and when we introduce, when you have Alaskan bush pilots and all of those areas have their own unique areas of challenge and skill sets. And so this is just one more. This is just the new, the latest, greatest introduction. But again, to that same point that I'll come back to, it means we have to look hard at training and education, how we deliver it, what we do. We can't throttle back on safety research to talk about, this is a whole new world from barnstorming. So what does that mean on the human factor elements and all of those areas? So I would just say, yes, I certainly recognize the different environment, but that has really opened the door to us for rethinking what we do in training and research.
But one additional comment that sparked from Becky is, you go back to JFK's famous speech about the Apollo program, and we do these things not because they're easy, but because they're hard. I do think this is actually one of those pieces around purpose and excitement, right? Engineers want to work on some of the hardest problems they can face, right? Engineers want to work on things that are not obvious, right? They don't want to. I mean, I always say when I came out of aerospace, the coolest job I could get was redesigning the magazine rack on the 767. That was not very exciting. Well, today you can solve the problem of flying in urban canyons with electric vehicles. So yes, it's hard and challenging, but that's what makes it exciting. And especially, I think, for the new generation.
Well, thank you. Unfortunately, we do not have time for another question. There were some very good ones, so thank you, those of you who submitted them. I'd really like to thank both Robin and Becky for joining us today. This was a perfect ending for this series. And thank all of you for your participation. I can't remember a series where speakers have so routinely mentioned prior speakers and integrated what they're saying into what we've heard earlier in the series. So it's been great that even the speakers have been tracking the series as a series. But thank you for your valuable perspectives on the future of aviation and the AAM workforce. We hope to see all of you at our future thought leadership events. And we will be posting our final report on this series this spring. So thank you all for engaging and have a great day. And my thanks to those of you who have in the background kept the series going technically, and to Ellen Bell for conceiving of the series and pulling together the speakers with Terry Wadley's assistance. It's just been a great team. So thank you, everybody, and have a great afternoon.